200 years of modern science, we have to admit that our performance is not great. The machines we build continue to suffer from mechanical failures. The houses we build do not survive severe earthquakes. But we shouldn't be so critical about our scientists for a simple reason. They didn't have much time. 200 years is not a lot of time, while nature had 3 billion years to perfect some of the most amazing materials that we wish we had in our possession. Remember, these materials carry a quality assurance of 3 billion years. Take, for example, sequoia trees. They carry hundreds of tons for hundreds of years in cold weather, in warm climates, UV light. Yet, if you look in the structure by high-resolution electron microscopy, and you ask yourself, what is it made of? Surprisingly, it's made of sugar. Well, not exactly as we drink in our tea. It's actually a nanofiber called nanocrystalline cellulose. And this nanocrystalline cellulose is so strong, on a weight basis, it's about 10 times stronger than steel. Yet, it's made of sugar. So scientists all over the world believe that nanocellulose is going to be one of the most important materials for the entire industry. But here's the problem. Say you want to buy a half a ton of nanocellulose to build a boat or an airplane. Well, you can Google, you can eBay, you can even Alibaba. You won't find it. Of course, you're going to find thousands of scientific papers, and great papers where scientists are going to say that this is a great material. There are lots of things we can do with that. But no commercial source. So we at the Hebrew University, together with our partners in Sweden, decided to focus on development of an industrial scale process to produce this nanocellulose. And of course, we didn't want to cut trees. So we were looking for another source of raw material, and we found one. In fact, the sludge of the paper industry. The reason? There is a lot of that. Europe alone produces 11 million tons of that material annually. It's the equivalent of a mountain 3 kilometers high sitting on a soccer field. And we produce this mountain every year. So for everybody, it's an environmental problem. And for us, it's a gold mine. So now we are actually producing on industrial scale in Israel nanocellulose, and very soon in Sweden. We can do a lot of things with the material. For example, we have shown that by adding only a few % of nanocellulose into cotton fibers, the same as my shirt is made of, it increases its strength dramatically. So these can be used for making amazing things, like super fabrics for industrial and medical applications. But this is not the only thing. For example, self-standing, self-supporting structures like shelters that you can see now actually is now showcasing in the Venice Biennale for Architecture. So, nature actually didn't stop its wonders in the plant kingdom. Think about insects. Caterpillars, for example, have the ability to jump about 100 times its height. And that's amazing. It's actually the equivalent of a person standing in the middle of Liberty Island in New York, and in a single jump go to the top of the Liberty statue. I'm sure everybody would like to do that. So the question is, how caterpillars do it? It turns out that they make this wonderful material which is called resilin. In simple words, resilin, which is a protein, is the most elastic rubber on Earth. You can actually stretch it, you can squish it, and it doesn't lose almost any energy to the environment. Now, when you release it, snap, it brings back all the energy. So I'm sure everybody would like to have the material. But here's the problem. To catch caterpillars is difficult. Why? Because they're jumpy. But now, it's actually enough to catch one. And now we can extract its DNA and read how cat-free makes the resin and clone it into a less jumpy organism, like plant. So that's exactly what we did.